Welcome to the class of Big Data Analytics. I am Dr. Shanmugapriya, belonging to Computer Science Department. I am going to give a lecture on Introduction to Big Data Analytics. In this lecture, I am going to talk about Big Data overview, state of practice in analytics, business intelligence versus data science. Before going to see all those things, let me see what do you mean by big data. Big data refers to a huge volume of data. It is measured in terms of terabytes or nowadays in petabytes. That means the data generating rate is an increasing order because of the usage of mobile phones, digital wallets, social media. Sometimes imaging technology it is used for determining the medical analysis or medical diagnosis. We are creating a more new data with respect to already existing one. Sometimes the devices there are a lot of sensors available, though that sensors they are generating diagnostic information that is need to be processed in real time application. See, for example, a car company called Tesla company, it consists of the car consists of a number of sensors in order to monitor each and every action that was done by the car. So, analyzing vast amount of data when it does not come into the data structure or we cannot able to identify a meaningful patterns or sometimes extracting an useful information, it becomes a big challenge in big data. Now, let me see what are the areas that the big data covers. The first one is nowadays the business sector, government agencies, and all kind of sciences and everyday life is merged with the big data. Let me see the domains that are covered by big data one by one. The first one is credit card companies. Nowadays, every person who are using or purchasing, sometimes making their transaction with the help of credit cards. So, in order to find the fraudulent purchases, high degree of accuracy will be maintained by each and every banking sectors. So that is a very big domain of big data. And second one is mobile phone companies. They are analyzing subscribers in order to using the frequent calling patterns. Say for example, an organization who want to communicate a particular conduct frequently. In those situations, they go for patterns. Sometimes the social media network like LinkedIn, Facebook, Twitter, the value of data it is in growing order. So these areas the big data domain covers. Let me see what is referred as big data. That means let me see some of the attributes or characteristics of big data so that we could able to identify whether we are in the big data domain or not. The first one is big data characteristics or measured in terms of V's. There are several V's available in order to categorize the big data. Whereas we are using only three V's: volume, variety, and velocity. Huge volume of data. That means every day the data is generated. Not even every day. We can say every nanosecond a data is generated by the user. So there are millions and trillions of columns and rows of data. And second one is complexity of data type and structure. While talking about big data, the volume of data is increased one, and also the data sources format. There is a no predefined format of data. Since some of the organizations, they are providing structured data, sometimes the Facebook and Twitter, like social media, they are generating an unstructured data. Sometimes the mail communication might be in the order of semi-structured data. So the pattern of data is not a predefined one. That is the second, that means a variety of data. And finally, we can say that we are working in data, big data analytics domain, like the data transferring from one network to another network, or one devices to another device, or it might be one to another in a fraction of second. That is every nanosecond the data is generated. So the speed of new creation of data and growth is measured on another way. So there will be and scalability, distribution, diversity, or timelines. It is needed while a new kind of business value is going to implement. See, these are some of the sectors that the big data domain areas: mobile sensors, social network, video surveillances, video rendering, gene sequencing, medical imaging, geophysical exploration, and smart grids. Social media and genetic sequence or Facebook. Let me see. The first one is Facebook. While posting each and every seconds, minimum 700 status or updated per second all around the world. This is the measurement that was taken in the year of on the year of 2012. Sometimes the user in Facebook, they want to update their status like single, engaged. Sometimes they are going for purchasing a bridal dress and wedding plans. They do updating their pictures or post in social group of network. So the integrated network in that is the social media network, and in the year 2013 they introduced a feature of graphic search. In graphical search, the user can able to pin their interest, like similar interest or hobbies, or they can share some what place, or they can share the location they want to say. Then next one is genomics. Genetic sequence and the human gene mapping is provided and understanding in the study of genomics. And a person, like what it covers is, it cover about the prediction of disease in the person's lifetime, and what are the medicines they are taking, and however the treatment is going on. All those things are covered in genomics. Then data structure, as I told you, the data is in increasing order, data generation is in increasing order. So we divide the data structure into structured or non-structured data, such as financial data, text files, media files, and also some of the genetical mappings. We can say the data structure is divided into four types, like structured data, semi-structured data, quasi-structured data, and structured data. We have different set of structures available. Why? Because it's in order to process the complex data. The semi-structured data, or else the quasi-structured data, The best example for the semi-structured data is call logs. In all our mobile phones, we have a call informations available. Sometimes the mail ticketing informations or customer chat history or transcript of phone call description. These are some of the examples of quasi-structured or unstructured, or we can say it is a semi-structured data. And there will be a category of structured data. It consists of a table with rows and columns. Sometimes you can use timestamps. Sometimes it might be a predefined order like from to, then body of the text, and the end of the footer column. So it consists of a predefined data structure. So while consolidating about the data structure, the structured data is in the topmost order. Then we may have semi-structured, quasi-structured, and finally unstructured data. So the structured data, it might be, I already told you this, there will be specific format available. That format file like a dot CSV file, like text file, data files, or else XLS file. So these are some of the examples. Semi-structured data. Semi-structured data, it consists of the patterns in addition to a normal text. Like it supports the language called XML language. You can have your own tag. There is a quasi-structured data. In this quasi-structured data, the format of information is from different kind of tools with different time strands available. And finally we have unstructured data. Unstructured data, you have all the text documents, PDF files, images, uh, and all kind of social media network databases, or some of the examples of unstructured data. Now let me see the business intelligence versus data science. The business intelligence refers to a set of technologies, applications, processes that are used by an enterprise for their business deals. It is used for conversion of raw data into meaningful information, which is thus used for business in order to making some decisions, or in order to getting profitable actions. So this analysis is sometimes called it as structured analysis. Sometimes it might be an unstructured format. That is, they are implementing their new kind of tools, like decision making tools, some assumption based decision making. So in those situations, they may be an unstructured data. What do you mean by data science? Is data science generally, it's a basically a field of information or knowledge that are extracted from the data by using various scientific methods, algorithms. There will be some processes. Thus, we can define a combination of various mathematical tools, algorithms, statistics, machine learning techniques. They are used for finding the hidden patterns in order to making the decision support process. So data science, it deals with both structured as well as unstructured data. So the unstructured data, sometimes we need to provide a historic trends and the conclusion of redefine the present of predicting future patterns and trends. We go for data science. So generally the data scientists, they are only focusing on patterns or correlation models, whereas business intelligent analysis, they deal with reports. They go for KPI or trends. The data is static in business intelligence and it is a comparative, whereas data scientist, in here the data is an exploratory or experimentation, and we do some visualization tools. The process rate is pre-planned one. So we do the processing in slow manner. Whereas data science, the patterns are generated as the user need. So we plan the database as a front-end tool. Sometimes it may be a back-end tool. Whereas in case of data scientists, as per the user requirement, as per the user on demand, the data insights of databases is defined. It's a single version of truth. It is a good probabilitics. Schema on load, and here the schema is just like a query. Whereas business analytics, it's a retrospective, or else we can say it is a descriptive model. Whereas data scientist, it is a predictive or prescriptive privileges to reach and leverage. And predictive analytics and data mining activities are last in line for data. Why? Because the predictive analysis is used for improving the business profitable, and also the EDW are designed for central data management and reporting in order to get some patterns and store the data using some enabled resources. Data move in batches from EDW to local analytical tools in order to do the decision making systems. There are number of in-memory analytics, like there are so much of big data analytic tools available. I have sticked out some of the examples here. R tool, SAS, SPSS, and of course Excel tool. Data science projects will remain isolated and ad hoc centrally. Drivers of big data. Medical information such as genomic sequencing and diagnosing images. These plays a very big role in medical analysis. Photos and video footages uploaded in W3. The video surveillance, such as thousands of video cameras that are located all over the city, and mobile devices, which is used to provide a geospatial location of data to the user. There are such a kind of metadata about text messages, phone calls, and applications usage on smartphones. Smart devices which provide sensor-based collection of information from smart electrical grids, smart buildings, and many other public and industry infrastructure. Non-traditional IT devices like radio frequency identification readers are there. In addition, we have GPS navigation system, seismic processings. These are some of the drivers of big data. And then we are going for a new approach to analytics. In that new approaches, we have data devices and sensor net that is used for gathering the data from multiple locations continuously without any interruption. Gigabytes of data are created daily. For example, there are a lot of video games, smartphones, retail shoppings available. With the help of these things, we can collect the data from different sources, and there will be a data collectors available. The example for collectors are retail stores. They are nowadays collecting the data. Even in cable TV providers, they are tracking the system so that their TRP rate will be increased. Then there will be some data aggregators available. These data aggregators are used for collecting data from SensorNet or any other IoT devices. Nowadays, government and government agencies, retail stores, and websites, they are compiling and collecting the data according to the usage patterns. And in addition to all those things, nowadays the online society, e-com industry, they have list of brokers available. They have some marketing trends to reach the product to the end user, so that they can reach the good target. And there are data users and buyers. There are different groups of collector data users are there. They are aggregating the data. The retail banks also, they are collecting the data as per the mortgage values on home loans. They purchase the data. They purchase the data from the bank by means of data aggregator. Nowadays, data aggregator, they aggregate the data where the data uses are there. There are some kind of new technologies such as Hadoop to perform the natural language processing or unstructured textual data from social media websites. There are a lot of vlogs available and online comments available, which is used to lead a sentimental analysis, geographical area, or tweeting in social media in order to know the natural disasters. So the data devices are there. The data devices, from the data devices, the data collectors are collecting the data, and though the data is aggregated by means of data aggregators, and the data users are data buyers who buy the data from this data aggregator in order to promote their business or the geographical location. We will know the natural disasters. So these are the areas, these are the technologies that big data used nowadays. Hope this lecture, it is used to know about how the big data grows. In addition, we know about what are the characteristics of big data and how the big data is grown nowadays. The technologies, how it is used to predict the patterns. What are the technologies nowadays available in order to do the big data in effective manner? Thank you. Let me meet in another session with some other new topic. Thank you.